Okay, we now move on to question 4. This is about the Bernoulli differential equation. dy dx plus p of x times y equals to q of x times y to the n. Here we'll make the assumption that n is greater than or equals to 2. P of x and q of x are just some functions in terms of x. We understand that the equation is linear for n equals to 0 or 1, and we could solve it via some of the techniques that we know of, such as separation of variables and integrating factors. But let us focus on the case when n is greater than or equals to 2. So, using this substitution, u equals to y to the power of 1 minus n, that we can transform the equation into the form du dx plus 1 minus n times p of x times u equals to 1 minus n times q of x. Okay, so we need to take our original differential equation, apply our transformation, and obtain this form. This is a first order differential equation in terms of u and x. So we need to get rid of the y. How can we do this? Well, first we should simply differentiate u with respect to y. U is something that we treat as a function in terms of y. So when we differentiate that, we should take the power 1 minus n and bring it down and subtract 1 from the power, so it should become y to the minus n. That's du dy. And now we need to perform all the necessary substitutions for y and dy dx in order to obtain the answer that we want. Okay, what we want is this. On the right hand side, I have 1 minus n times q of x. But on the right hand side, in my original differential equation, I have y to the n. So I need to get rid of it. I need therefore to multiply through, or rather I should divide throughout my differential equation by y to the n. And that is what I can do, provided that I assume that y is not equal to 0. Once I make this assumption, you can see that I can divide everywhere by y to the n. My right hand side just becomes q of x. I multiply y to the n, or I divide by y to the n throughout, and so this y would become y to the 1 minus n, and I will of course multiply y to the minus n to dy dx. The next aspect of the right hand side in what I want is that I should have 1 minus n times q of x. So I would then multiply throughout by 1 minus n. That is the next step. 1 minus n multiplied to every term in my differential equation. Here is where we observe that things start to fall into place. Y to the 1 minus n is precisely u. U equals to that. So we replace it with u. What about this term over here? 1 minus n times y to the minus n. That is precisely du dy. And we replace it with that. And that means that here, in the first term, we have du dy times dy dx. And simply by applying the chain rule to this, we convert it straight away to du dx. And as you can tell immediately, this is the differential equation that we want, that we are supposed to get. The differential equation in terms of u and x that we are supposed to find. It's precisely the same thing here. Okay, so that solves question 4.